Let's see this question. This question is given in GATE 2012 in the subject EDC. The CMOS circuit shown here, electron and hole mobilities are equal. Also M1 and M2 are equally sized. This transistor M1 and M2 are equally sized. The device M1 is in linear region if they are asking the device linear M1 should be in linear region if with respect to input voltage if it is less than 1.875, option B 1.875 less than V in less than 3.125, option C V in greater than 3.125, and option D it is in between 0 volts and 5 volts. Okay, they are asking with respect to M1. For M1, first this given is CMOS transistor. CMOS transistor consists of one PMOS transistor and one NMOS transistor. The above one is PMOS transistor, here below one is NMOS transistor. For PMOS transistor, this is source, this is gate, and this point is called drain. Now, with respect to M1, they are asking whether it is linear or not. So it has to holds to one condition. Okay, device M1 is in linear region if it has to hold to one condition. Okay, linear region if VSD less than VSG plus VTH, where VTH equal to threshold voltage given as 1 volt. Now with respect to M1 transistor, we write VS1 minus VD1 less than VS1 minus VG1 plus VTH. VS1 got cancelled, minus VD1 less than minus VG1 plus VTH. You just multiply by minus VD1 greater than VG1 minus VTH. If you observe here, VD is nothing but V0. Okay, so in place of VD1 you can write V0 greater than VG. This is the gate, nothing but V in. VG is nothing but V in, and VD is nothing but V0, V out. Okay, so replace VG1 by V in minus VTH given as 1 volt. Okay, 1 volt. So this is the condition for M1 should be in linear region. Okay, now we have got the condition for M1 should be linear region, that is V0 greater than V in minus 1. Now we will try to look after with respect to the table V in, V out. V in is the input voltage, V out is the output voltage. Okay, now if V in is 0 volts, definitely V not equal to directly VCC, that equal to 5 volts. Okay, now if V in is at 5 volts, V not should be directly connected to the ground, that is 0 volts. If you observe clearly, V in is increasing from 0 to 5 and V naught is decreasing here. This is decreasing from 5 to 0. This is decreasing, this is increasing manner. So definitely if one value is increasing, another value is decreasing, at some point they will meet. Okay, where V naught is equal to V in is equal to VDD by 2. Okay, that is equal to 5 by 2 at 2.5 volts. At 2.5 volts, both gonna have same voltage. This point is called inversion point. Okay, at 2.5 volts, V in is same as V out. Okay, now we will take an intermediate value, that is between 0 to 2.5, let us say 1.875. it is increasing from 0 to this much, so output should be decreasing by this much. Okay, this will be 3.125. Similarly, here between 2.5 to 5, it's 3.125. It should decrease by the same amount. Okay, 1.875. Now we will take the condition and we will substitute these values. V naught greater than V in minus 1. Take the first value V naught equal to 5 greater than V in minus 1. 5 greater than minus 1, that is true. Okay, so this is satisfying. Now take the second value 3.125 greater than V in is 1.875 minus 1. This is obviously true. So second one is also satisfying. Now take the third one 2.5 greater than 2.5 minus 1. 2.5 greater than 1.5. This is also true. Okay, now take the other value this is V out is 1.875 my greater than 3.125 minus 1, 1.875 greater than 2.125. This is false. Okay, so these values cannot be true for this equation. If you observe clearly, for any voltage, okay, for any voltage, V in, if it is less than 3, then only these values are satisfying. For all the above 3 cases, if you observe, V in is less than 3, okay, it should not be equal to this also, it cannot satisfy. So in the options, what is the value which is less than 3 only? So option A is less than 3, option B is not less than 3 because it is having a 3.125, it is greater than 3, so C is not, option D is also not. So from the options, V in is less than 1.875 volts. If V in is at accepts this condition, then only M1 is in linear region. Okay, how we got the solution is, first we need to derive based on this condition. M1 is in linear region only if this condition holds true. VSD minus less than VSG plus VTH. VTH threshold voltage given as 1 volts, and with respect to M1 transistor, that's why we taken VS1 minus VD1, and we have found out the necessary condition. This is necessary condition such that M1 is in linear region, and we have to tabulate with some values. We know that for 0 volts, V out is 5 volts, and if V in is 5 volts, V out is at 0 volts. Then directly substitute in this equation and calculate what are all the values which holds true. So finally, if V in less than 3, then only M1 is in linear region. So answer is option A.